to Mathly. Today we are going to talk about perfect square. Lesson 3. Revision. The product of a consecutive positive integers is never a perfect square for k equals to 2 or 4.
And this result can be generalized as follows. The product of consecutive positive integers is never a perfect square. Instead of consider the product of consecutive positive integers, now we may want to consider the sum of consecutive positive integers. And we can ask the following question.
Question 1. Can the sum of two consecutive positive integers be a perfect square?
So these are examples of such sum. We can have 3, 5, 7, 9. Aha! This is a perfect square. 11. And see, we already have a perfect square, and obviously the answer is yes. Here are some observations. 4 plus 5 is equal to 9, which is 3 square. And you can have more sum of consecutive positive integers such that it is a perfect square. 12 plus 13 is 5 square. 24 plus 25 is 7 square. 40 plus 41 is 9 square. Look at this number carefully. 3 square plus 4 square equals 5 square. 5 square plus 12 square equals to 13 square. 7 square plus 24 square equals to 25 square. And 9 square plus 40 square equals to 41 square. Is this only coincidence or it is always true? Now what's the meaning of 3 square plus 4 square equals 5 square? We may think about Pythagorean theorem. We can have such right angle triangle. Similarly, we can have some other right angle triangle as shown. Now in general, we can write it as 2n multiplied by 2n plus 1 plus 2n multiplied by 2n plus 1 plus 1. And the result will be a perfect square, which is 2n plus 1 square. It means that we can have such right angle triangle. So we can state the following result.
Suppose b and c are consecutive integers with b is smaller than c such that b plus c equals to a square, then a square plus b square equals to c square.
Next, we can ask the following question.
Question 2. Can the sum of four consecutive positive integers be a perfect square?
Now let's look at some example of such sum. So we have 10, 14, 18, 22, and 26. Note that none of these is a perfect square. The answer is no. And why not? So these are the sum of four consecutive positive integers. It can be written as 2 multiplied with 2k plus 3. 2 is 2, and 2k plus 3 is an odd number. Notice that all even perfect square is a multiple of 4. And 2 times odd is never be a multiple of 4. So it concludes that
the sum of four consecutive positive integers is never a perfect square.
Conclusion. Suppose b and c are consecutive integers with b less than c such that b plus c equals to a square. Then we have a square plus b square equals to c square.
The sum of four consecutive positive integers is never a perfect square.
And this end of our lesson 3.
Hope that you enjoyed the lesson. Thank you.
And bye bye.